Hello everyone, welcome to the video lecture series of operating system. In today's session, we are going to continue with the topic process synchronization. Specifically, we are going to discuss one more classical problem of process synchronization in this particular session. Myself, Kunal Panchal, your instructor. In this particular session, as I told you, we are going to discuss one more classical process synchronization problem, which is nothing but monitor. In earlier sessions, we have discussed many classical process synchronization problem like producer-consumer problem, dining philosopher problem. Then we have discussed Peterson solution. Okay, so these are the various process synchronization, classical process synchronization problem we have discussed. Now one more problem we are going to discuss, which is nothing but monitor for process synchronization. Okay, so let us start with the monitor. In the case of monitor, so before going to directly jump into the concept of monitor or process synchronization problem, okay, in the case of monitor, first of all we need to understand the problem, okay, because we need to understand the race condition that we have already understood, but still we need to start with the what is race round condition and how we can solve that problem with the help of this solution. Okay, so you can see in this particular figure there are three different data we have called A, B and C. You can see A, B, C are nothing but the shared data, and these shared data can be accessed by any processes. So in this case we have taken two processes P1 and P2. So these A, B, C can be accessed by P1 and P2 at any moment of time. Yes, because these three data is nothing but shared data. Okay, so in this particular example we have considered P1 is accessing B and C data. At the same time, if P2 want to access C data, but C is right now accessed by P1. So if more than one process are trying to access the same resource at same amount of time, that leads to inconsistency. Okay, that may leads to inconsistency, and that is nothing but the race around problem, or we say race condition. Okay, and to avoid this problem, so this is one problem. Okay, race around condition, or we say racing is one of the problem. It may lead to inconsistency of data, so that we can easily understand with the help of this figure. So how we can solve this problem? So let us discuss about solution. So in this particular case, we have taken one one resource allocation algorithm which is responsible to manage these resources in a we can say mutual exclusion fashion. Like if any process is accessing a particular data, at that time no other process can allow to access that data. So that resource allocation, in this case resource allocation algorithm will take input from the P1 process. Okay, and at that time if no and P1 require resource, say for example A, and at that time resource A is free, so resource allocation algorithm will check whether this resource is busy or free right now whenever any request arrived. So right now that resource is free, so resource allocation algorithm will give that resource A to process P1. Now P1 is accessing A, but during the execution of the P1, P2 also requested to the same resource A, but that request is blocked by this resource allocation graph. So this block request I have represented in terms of the black arrow, you can see. Fine. So P2 won't allow to access the resource A right now. Okay. So in this way you can avoid the inconsistency. Fine. So now that resource allocation algorithm that we have discussed in the previous session, let us now concentrate on monitor. So what is monitor actually? So monitor is one type of we can say class, or we can say one type of module in which it contains shared data, set of procedures, and synchronization between concurrent procedure invocation. Means you can see in this particular figure, the monitor block contains two information. One is shared data and set of procedures. So what is procedure, that we are going to discuss in clear-cut way, but these things you need to keep in your mind. A monitor is a module which contains, or we can say which encapsulates shared data structures. So A, B, C is nothing but shared data structure in this case. Then it contains procedures that operates on the shared data. Yes, these are the procedures that can use to access the shared data. Fine. And the third one is synchronization between concurrent procedure invocation. Means synchronization should be there to achieve consistency, to avoid inconsistency. In that case, synchronization between procedures should be there. Okay. One more thing we will discuss in later slide. The monitor contains one more thing is conditional variable. So what it means, that we are going to discuss in upcoming slide. So right now we have focused on this the module monitor module. Now in this case, for example, suppose if you have P1 and P2 process, how actually monitor module works, that we are going to discuss now. So suppose if you have this P1 and P2 process, and P1 is requesting, P1 want to access resource A, for example, or shared data A in this case. So when we are talking about monitor, in this case, process cannot directly access to the shared data. Okay, when process required to access some shared data, so that request would be forwarded to the monitor module first. Okay, so what, that request will be forwarded to monitor, and as I told you, monitor contains basically two things in this case. Shared data, it contains shared data as well as the set of procedures. So what will happen in this case, when request arrived to the monitor from P1, so monitor will check, this monitor module will check, is there any other request arrived already to access this data or not. If the answer is no, in that case it allows to access that data through procedure only. Means that process request needs to be forwarded to the procedure first, and then with the help of procedure will access that shared data and get back to the process. Fine. So process cannot directly deal with shared data in the case of monitor. That things to keep in your mind. Okay. So once the monitor allows a particular process to enter into it, in that case one lock is associated with it. So lock is associated with P1 process, because right now P1 acquire the monitor module in which that process is going to access the resource A. Fine. So whenever any process allowed to enter into monitor, so that process will be assigned a lock, so that another process cannot enter into a monitor. That thing should keep in your mind. Why we are using this locking mechanism? To achieve to achieve process synchronization in a better way, through which we can, just like this monitor can work as a critical section. So critical section, like in critical section only one process can enter into a critical section at a time. Same way in the case of monitor, at a particular moment of time, if you are talking about process or we can say thread, it can enter into a monitor at a particular moment of time. Only one process or it is only one thread can be allowed. Whether we are talking about multi-threading or multiple threads, so only one thread can allow to enter into monitor at a particular moment of time. Same way if we are talking about multiple processes, in that case only one process is allowed to enter into a monitor, so that we can achieve the consistency at the end. Fine. So this is all about the brief idea about monitor module. Okay, so these things you have to keep in your mind. These block is assigned to a particular process which is allowed to access the shared resources which is located into a monitor module. Okay, now in this particular figure, now P1 is accessing, in this case P1 is accessing resource A which is shared. So at the same time, while P1 is accessing resource A, meanwhile P2 sending a request to access the same resource at same amount of time. So in this case what will happen? So as I told you, this request will be blocked by the monitor because the lock is already assigned to a P1 process and P1 is using that resource A. So P2 request would be blocked by the monitor. So as I told you, only one thread can enter into a monitor at any moment of time. Clear? Okay. Now, one more thing you have to keep in your mind. As I told you, P1 is already using, entered into a monitor. So it means what P1 is, in this case you can easily understand. P1 is already entered into a monitor and P1 is using, shared resource A. Okay. But at the same time, if another process is requesting, that process would be stored in a monitor queue. Means what? The monitor will maintain one queue in which the upcoming, or you can say waiting process, would be stored for a while. So this blue block is nothing but a monitor queue in which upcoming, or you can say waiting process can store for a while. Clear? Okay. So this is a very basic or simple code of monitor, in which monitor, then monitor name I have suggested account. Then in this case we have one shared variable called balance variable, and it is double type of variable, and we have used one procedure in this case. So as I told you, monitor module contain two things. One is shared variable and second one is procedure. So withdraw is nothing but my procedure. So withdraw of amount, in which there are two instructions. Balance is equal to balance minus amount, and returning, I'm returning the balance. Once this withdraw operation is called, it will deduct the requested amount from the balance, and it will return the updated balance to the database. Okay, so, or to the user we can say. Fine, so this is a small code. So how this code will work? Suppose if we have three different threads, you can see T1, T2 and T3. These three are nothing but threads. Okay, and you know very well what is thread. Thread is nothing but a part of process. Fine. So say for example, this code will be executed by these three thread for example. So T1, suppose T1 is, means all these threads requested to access this monitor at the same amount of time, but at a time, as I told you, monitor can only allow only one thread into the monitor for execution. So only, so for example, in this case we have considered T1 accessed the monitor, and it succeeds to access the monitor. So it enters into a monitor, and now it is executing this withdraw procedure. So withdraw W, then it will deduct the balance. Balance is equal to balance minus W. Okay, and once these two instruction is executed, now the context switch is happened. Means what, in the case of multi-threading environment, so definitely the context switching can be possible. So now the thread switching would be happen, and the execution of T1 is temporarily suspended, and it will give to the T2 for its execution. But now T2 is requesting to execute the withdraw procedure, but that procedure would not be executed by T2 because this request would be this request of T2 would be blocked. Why? Because this withdraw procedure is already executing by the T1 procedure. So these requests will be blocked. Now again T2 is temporarily blocked, or in case it is in waiting mode. So now again context switch will happen, and it will switch to, say for example, T3. Fine. So again T3 wants to enter into a monitor. So definitely these requests will be blocked because already the locked is assigned to T1. So nobody else can enter into a monitor to access this particular procedure, to access this shared variable and execute this procedure. Fine. So again T3 is not allowed. So again control will switch back to the T1, and T1 will execute the remaining instructions. And once T1 finish its task, then the lock would be released by the monitor, so that other threads can use these resources or shared resources. Fine. So T2 can resume its execution, and once T2 is completed its task, then T3 can execute its own task. Fine, by using this shared variable and procedure. And so in this way this monitor works in the case of multi-threading environment. Fine. Now, as I told you, one more thing we need to understand in the case of monitor. So right now we are in this particular figure, you can see we are going to discuss the producer-consumer problem with the help of monitor. So again we have one monitor in which one buffer is there, and buffer is nothing but a temporary storage, and that buffer is nothing but shared data. You have to assume buffer is nothing but shared data, because we are talking about producer-consumer problem, and that we have already understood in the previous sessions. Fine, of process synchronization, that things you need to keep in your mind, and according to that you need to understand this topic. So we have one buffer which is shared, okay, and we have two procedure. One is put item and second one is get item. So put item and get item. So, and we have two processes, P and C. P stands for producer and C stands for consumer. So producer will produce something. So producer will call the put item, and with the help of put item it will insert some data into a buffer. And same way consumer will consume something. So consumer will get something from the buffer. So consumer will call the procedure get item, and through get item the content of buffer will be fetched and give it to the consumer. So these two procedure we have, and two processes we have, and one shared buffer we have. And initially this buffer is empty, that you need to assume. Okay. So in earlier case, till now we have discussed, we have achieved a proper process synchronization with the help of locking mechanism. Means what? If any process is allowed to enter into a monitor, no other process can enter into a monitor at that time until it releases the lock. Fine. So that we have, means what? The critical section problem is what? At a particular moment of time, only one process can enter into a critical section. Same way we have achieved that stuff, but there is one problem. When we are talking about producer-consumer problem, so two techniques or two conditions we need to check. One is underflow and second one is overflow. So what will happen in this case? Let us take one one scenario. Suppose buffer is right now it is empty initially, fine. Now consumer is requested to enter into a monitor. So right now no other request is there in the monitor. So definitely monitor will allow to enter the consumer into the monitor. So if consumer will access it first, then consumer will enter into a monitor and find buffer is empty. So what will happen? So what is the task of consumer? Consumer will consume something from the buffer. But right now buffer is empty. So it is nothing but underflow condition. So once it entered into a monitor, now what consumer will do? Consumer can do nothing in this case, even though it succeeds to enter into a critical section, or you can say monitor in this case. But that consumer has to wait for to get something from the buffer. So now it is in waiting mode. So this is one problem. Yes. So if producer now produce something at the same time, it can't, because monitor won't allow it to enter into the critical section. Yes, because consumer is already entered into a monitor. So as you know very well, at a particular moment of time only one process is allowed to enter into a monitor. So consumer is entered into a monitor already. So now producer wants to produce something, or we say insert something into a buffer, but that request will be blocked by the monitor. Yes, because already one process is there. So there is one problem in this case, because P1 cannot, means a producer cannot enter into a critical section, or we can say monitor. At the same time, consumer is already entered into a monitor, but the consumer cannot do anything because buffer is empty. So this is one problem. So how we can resolve this problem? So not only outer side we need to have process synchronization. Means so far we have discussed the process synchronization at outer side. Means only one process is allowed to enter into critical section. But once any process enter into critical section, okay, so within the critical section we need to have process synchronization as well. So to resolve such type of problem, we need to have this conditional variable which provides synchronization inside the monitor. This is very important concept in the case of monitoring, that you need to keep in your mind. So locking mechanism provides synchronization between process at outer side, but within the monitor or inside the monitor, if you want to achieve process synchronization, you have to use conditional variable. Okay, so what will happen in this case? If a process wants to sleep inside the monitor, because in this case consumer is already entered into a monitor, now there is no data to consume in the buffer because buffer is empty. So that process needs to sleep for a while, okay, until it gets data from the buffer. So if a process wants to sleep inside the monitor, or it allows a waiting process to continue, in that case conditional variable are used in monitor. So if you want to make that process in a sleep mode, okay, or we can say in waiting mode, so we need to use this conditional variable within the monitor. So there are three operations can be performed on this conditional variable. First one is wait, second one is signal, and third one is broadcast. So let us discuss these three types of operations that we can perform on conditional variable which resides in monitor module. Okay, so let us discuss what wait means. Wait operation means if a resource is currently not available, so obviously consumer is already entered into a critical section, or you can say already entered into a monitor, fine. So but that resource cannot be utilized by consumer because there is no content available in buffer. So that current process put into a sleep and it release the lock for the monitor. So what wait operation will do? It will, if resource is not available for a current process which is already reside in the monitor, so with the help of wait operation, the current process would be put it into a sleep mode, or we say in waiting mode, and it release the lock so that other process can enter into a monitor. So it release the lock for monitor. So this is the task of wait operation. Now second is signal. What signal will do? So signal operation wakes up one process which are sleeping as a result of call to wait. In this case, a waiting process to resume immediately means what? When signal is called, this signal operation will be called. In that case, what signal will do? Signal will fetch the data from the buffer. In this case, conditional variable we have, okay, which resides in this module. So it will fetch that data and give it to resume its execution once it resides in buffer, because with the help of wait operation we have put that current process into a conditional variable queue, we can say, that we are going to discuss. One more queue we need to maintain, okay. So that current process is located into a conditional variable queue. So that process will resume its execution when signal is called. Fine. So the lock is automatically passed to the waiter. The original process blocks in the case of signal operation. And third one is broadcast. So broadcast operation signal to all waiting processes. This is what it will broadcast the signal operation to all waiting processes. Fine. Okay. Now let us discuss how this wait and signal operation works actually in the case of monitor. So this you can see wait condition variable dot wait and condition variable dot signal. It means what? Condition variable is the name of the queue of a condition variable, and dot wait and dot signal is nothing but these two are the operations that we can perform on the monitor. Okay, so with the help of conditional variable. Fine. So in this case, what will happen when conditional variable dot wait is called? What will happen? So as I told you, wait operation will do what things? It will current process will forward it to the conditional variable queue, and it will store for a while in a queue when wait is called. Now when signal is called, so this P, you can see in this particular figure we have one process which is waiting in a queue. This queue is for conditional variable. Okay, so that P, when signal is called, P will be resume its execution, because now the resource is available for access. Okay, so let us discuss this thing with the help of one example. So in this case, you can see one block we have. So we are going to discuss the monitor problem with the help of single shared resource variable we have, and according to that we are going to discuss this example. So R is nothing but single shared resource that we have. Acquire and release, these two are nothing but two different procedures we have. BZ is nothing but a boolean type variable that we need to initialized by false, because it is a boolean type variable. So either the value of BZ can be false or true. Fine. So initial value of BZ variable is set by false. Okay. Now one more, we have buffer that I already told you, the conditional variable buffer. That buffer will store the waiting process for a while. okay, until it gets the resource for execution. Fine. So that conditional variable we have taken in this case, and you can see the code of this particular monitor in which we are using single resource. So single resource we have in this case, we have taken one variable called busy, and it is boolean type of variable, you can see in the figure. Okay, and one more you can say condition variable we have taken. So the name of the conditional variable is what? Non-busy. Okay, it is nothing but non-busy. Okay, now there are two operations or two procedures we have discussed over here: acquire and release. So what acquire will do? So it means what? Again, it is kind of get and put. Fine. So acquire is nothing but we are putting something, and release means what? We are fetching something. Fine, like that. So that we need to assume. So acquire means in the case of acquire procedure, we have written two instruction. One is if busy. If busy, suppose if this procedure is called, acquire procedure is called, what this procedure will do? If busy means what? If busy is equal to true, but initial value of busy is false, yes, so it will go to the else part, and it will make busy as true. But if condition is true, okay, it means what? If it is not busy, in that case, okay, in that case what will happen? Yes, any procedure can access the shared resource. Fine. So if busy, then non-busy dot wait operation needs to be performed. Okay. If busy, initial value of busy is what? False. So right now this condition is not satisfied. Fine. Because it is not busy, it is available. Fine. So in that case, the conditional variable value needs to be called with wait operation. So wait operation would be called, and the process which is waiting is entered into this buffer of conditional variable. Fine. And when we are talking about release, when release is called, what release will do? When once the resource is used by any process, now we need to call the release. So release will make the value of busy variable as false, and it will call no busy dot signal, so that the another process which is waiting in the queue can resume its execution. Okay. So let us discuss these things with the help of one example in which we have P1 and P2 processes, and sr.acquire and sr.release. In between these two procedure, we have written some code. Okay, the random code we have. So we have two processes, and these two P1 and P2 process wants to enter into a critical section at same moment of time. So what will happen in this case? So in this case again we have set, as I told you, initial value of busy is false. Okay, and we are talking about single resource monitor. Fine, single resource monitor we have taken. So now if these two processes send a request to access monitors at the same amount of time, only one process can able to enter into a critical section or just enter into a monitor. Yes. So P1, say for example P1 successfully enter into a monitor. Now what it will do? It will call the acquire procedure. Means what? It will execute the acquire procedure, in which that code we have already understood. Means if busy means what? Yes, it is busy. No, it is not busy. So what it will do? So if busy means what? If busy is equal to true? No. Yes. So what we need to do is, in that case, resource is available. It means what? The resource, the shared resource is available right now. So P1 can access that shared resource. So then it will call the non-busy dot wait. Means what? Wait operation needs to be performed. Okay. for this particular process by using this acquired operation. So, and if it is false, means what? If else part is there, in that case BC needs to be true. It means now P1 is accessing this resource, so nobody else can use this resource. So that's why we have put it in else condition. BC is equal to true. Means what? You can see in this particular figure now P1 is allowed to enter into monitor. So acquire would be called yes. So you can see the arrow. So acquire is called, once acquired is called, acquire through acquire operation or it is a procedure, we can access the shared resource. Yes. Once it is P1 is accessing the shared resource, at that time the BC no one else can enter into a monitor and access the shared resource. Yes. So if you want to avoid these things, again in the else part we need to set this BC variable value as a true instead of false, because when this value is true, it means what? Right now this resource is using by some process. Okay, so it is not allowed to use this resource right now. Okay, so P1 is right now using resource R. Okay, now P1 is during the execution of P1, meanwhile P2 is requesting to access the resource R. So it is requesting, the request is, I have represented with the help of dotted line. So what will happen when P2 requesting? So definitely the value is true. It means what? Resource is not available, so it needs to be executed. So definitely BC, obviously if this BC variable value is true, yes. So in that case what will happen? No BC dot wait operation needs to be performed. Fine. So it means that P2 process will temporarily enter into a conditional variable buffer. Okay, and later on, once P1 finishes its task, P2 will have the chance to execute on the monitor. Fine. So in this case, P2 is stored in the buffer of conditional variable. Now once P1 finishes its task, now P2 definitely can enter into a monitor and access this shared resource. Yes. So now P2 will execute the acquire again, and the value becomes false, because P1 is already accessed that stuff. Now the value would be reflected as a false. Now P2 is requesting, so definitely this request will be allowed by the conditional variable and it will be stored, it will be executed, okay, to use the executed on the monitor and use the resource, shared resource R. Fine. So if busy, then in this case what will happen again? Because if busy no, then no bus dot wait needs to be executed. Okay, when we are talking about release, so once any process execute task, like say for example P1, in earlier case P1 is already acquired that resource. Now once it is completed its task, it needs to be released so that other process can enter into a use the resource shared resource R. So it will call the release at the end, you can see, and busy value needs to be false. Yes, it will set the value by false, and then no busy dot signal would be executed, so that it means what? Once this statement is a signal operation would be executed, it means what? Now the waiting process, in this case waiting process is P2 now can able to access the resource R. So now P2 will have chance and it will execute this acquire, and again it will, once it is use that resource, and it will again release the resource at that time. Fine. So this is all about monitor, which is classical process synchronization problem. But when we are talking about this monitor, there are chances of a deadlock. So it is better to have semaphore as compared to monitor, because for implementation purpose it is very difficult, because it allows only one process at a time. So concurrency we cannot achieve in this case. That is the main drawback of monitor. It means the concurrency we cannot achieve, because at a time only one process can allow to enter into a monitor and use a shared resource. So definitely the concurrency is compromised. That's why uh, uh, semaphore is better solution as compared to this monitor. Okay, so I hope it was clear to you. Thanks for watching this video. See you in the next one.